Okay, let's start Unit 6. This is Section 6.1. The I can statement. Our objective for today is I can factor by substitution. And if you're in class, we'll do a quick draw and factor of the day or something like that. And what we want to do here is we want to talk about a different way of factoring and recognizing patterns and stuff. So a lot of math is recognizing patterns, and one thing we do to recognize patterns is we might rewrite it so that it looks a little bit more comfortable and a little bit easier. And a common technique that we'll use is something called a U substitution. So we're going to write the letter U right here, and we're going to focus on quadratics today. And when we take a look at this table right here, you can kind of consider this part of the practice and part of the learning that we're doing. This actually takes longer to explain. You'll notice that when we get done with this and we start doing some problems, it's actually pretty easy to do. But we want to spell out every single step here. So the first thing I want to focus on is this column right here. We're going to look at each one of these. The first four are trinomials. You'll notice that they've got three terms. And then the last one's a binomial. We'll deal with that one separately. So here's what I want you to notice. If I look at that middle variable expression part, the x squared part, if I were to double the exponent, it turns into a 4. So I want to recognize that pattern here and see if this holds. So this exponent is a 3. If I double it, I get a 6. This exponent is a 1/3. If I double 1/3, I do get 2/3. This one's a little bit more unique. This one is an x square root of x. But remember, the square root of x is exactly the same thing. If I do an exponent, it would be x to the 1/2. And if I were to take the square root of x and I squared it, so square it like this, I end up with an x. So if this is an x to the 1/2, this is an x to the 1, so those do match up. It matches this pattern that we're talking about. So this first one is done for us, and this is what we want to notice, is what we pointed out here. If I double this first one, so if I take an x squared and I square it, remember power to a power, I would multiply the two of those, I end up with a 4. So I can rewrite x to the 4th as an x squared squared. I can set off the x squared and make it clear to everybody with a set of parentheses. And then I can take this and I can change it. So if I recognize that wherever there's an x squared, I can put a u. I can put a u right here, so this would be u squared. I can put a u right here, so this would be minus 6u. And then I've just got the minus 7, the constant there. Let's take a look at this next one. Again, we key off this middle variable expression right here, x to the 3rd. So I'm going to write an x to the 3rd right here. So x to the 3rd squared is x to the 6th. I'm going to rewrite this so I can be clear. This is x to the 3rd right here. That's 5x to the 3rd. And I'm replacing x to the 6th with x cubed squared. So x cubed squared. And then I'm going to let u equal x cubed. So wherever there's an x cubed, I'm going to put a u. So this is 3x cubed squared. So this is going to be 3u squared. Just put a u right there. This is 5x cubed. So we're going to do a 5u because u is taking the place of x cubed. And then I've just got the minus 12 on the end there. So same thing here. Again, we're keying off that middle variable expression. So x to the 1/3 squared is the same as that first one. So we've got a 9x to the 1/3 squared. We've got a minus 12 x to the 1/3, and then we've got the plus 4. So we're going to let u equal that middle expression right there. So that's going to be x to the 1/3. And so I get to replace wherever there's an x to the 1/3, I get to put a u. So this is going to be 9u squared. Then this is going to be minus 12u. And we'll take a look at this next one. This one we need to figure out what's going on here. So what we noticed with this expression is that x, that first variable part, is the same as the square root of x squared. So if I take square root of x, square it, I get just an x. So I'm going to rewrite x as square root of x squared. Kind of a silly thing to do right now. We're going to set off the square root of x in parentheses so we can see that. And then we're going to do our u substitution. Our u substitution is u is equal to the square root of x. Get rid of that. It's equal to the square root of x. So wherever there is a square root of x, we're going to replace it with a u. So this is the square root of x squared, so that's going to be a u squared. This is the square root of x, so that's plus a u. And then we've got the 12 right there. Now, this one is different. This one is a difference of squares. So what we're going to do is we're going to say this. We're going to say x to the 10th is equal to the x to the something squared. So that would be x to the 5th. So I'm going to rewrite this as 16 x to the 5th squared minus 25. And then we're going to make this look a little bit easier by doing our substitution. So we're going to say u is equal to x to the fifth. And then wherever there's an x to the fifth, we're going to put a u. So this is going to be 16. X to the fifth is going to be a u. We'll square that, minus 25. So again, with the exception of the last one, these are all trinomials. And you'll notice that we take that variable expression here, double it, and we get the first variable expression there. So the exponent on the leading term is always double the exponent on the middle term, and that's the key to doing these. So we've basically done 5 problems like this already, and we're going to focus on a quadratic pattern as we work through this assignment. And just recognize that we can do u substitutions and substitutions of a lot of different types in many areas of math, but we usually just start with the letter u. I'm not sure why they chose that, but that's what they did. So all we're going to do here is we're just going to rewrite each quadratic with a u, and we're going to state what u is. We'll make sure that we do that. And then if it's not quadratic, we'll just write not quadratic and we'll just move on. So on this one, again, we recognize that if I double that exponent, I get x to the fourth. So we're going to state what u is. U is x squared. So if I need to, I can rewrite this as x squared squared plus x squared minus 12. And then I can just replace the x squared with a u. So this is going to be a u squared plus a u minus 12, and we're done right there. That's it. That's all we have to do. We'll notice on this one that missing exponent there is a 1. It's understood to be there. And if I were to double that one, I don't get 3. So that means this is not quadratic. So we're just going to write not quadratic. We're not going to be able to do this little substitution technique. So not quadratic. We'll just put a box around that. This one, we've seen this type before. So this is x to the 1/3. We're going to say u is equal to x to the 1/3. And then we're just going to replace this. So this is going to be 9u squared, because if I square 1/3, or if I double 1/3, I get x to the 2/3. And then minus 12u, and then plus 4. So we got that one taken care of. This one right here is a little bit different. It's got a square root and a fourth root. So what we need to keep in mind is, and I'm going to change colors for this, this is x to the 1/4, and x square root of x is x to the 1/2. So if I were to double this, it does work out. It fits that pattern. So what we're going to say is u is equal to the fourth root of x. So that means wherever there's an x to the 1/4, I can put a u, and this is, let's see, x, square root of x. Let me just write this out. Square root of x is exactly the same thing as the fourth root of x squared. So this does fit our pattern. So this is going to be u squared minus 7u plus 10. Okay, got that one. And then this is a big, long, ugly mess, but we can take care of this because they've set this off by putting it in parentheses. If I double that exponent, I get this exponent right here. So we're going to let u equal that variable part. So that's going to be 2x minus 3. So wherever there's a 2x minus 3, we're going to put a u. So this is going to be 2. Oops, I'll just write u squared. Don't need the parentheses. Plus u minus 1, and that's it. That's all we have to do. And then this last one, it is quadratic. It's not a trinomial or anything, but we're going to say u is equal to x plus 2. So this is going to be 4u squared, because we're putting a u in place of that, and then minus 1. So you might look at that and notice, well, all of these look simpler, but why on earth would we do that? And what is it that allows us to just kind of willy-nilly just change variables if we want? Okay, so we're going to take a look on the other side and realize what this does for us when we're factoring and how we can actually use that to go a couple steps further. Okay, so what we did on the previous side is we just did a substitution. We literally just changed variables. And in order to make that useful, we usually want to take a next step and actually do something with that. So here's what we're going to do. We're actually going to factor this. And we want to write the original expression in terms of the variable x, whatever the original variable was, and we used x on each one of these. So again, we'll recognize that this fits the pattern. X to the 6th is exactly the same as x cubed squared, so I'm going to let u equal x cubed, which means I can rewrite this one as 8u squared plus 2u minus 15. Now, once we get to right here, it looks better than the original one. We're going to use this to factor it. So I'm going to multiply the two of these together. This is a hard trinomial, so if I multiply those together, I get negative 120. I'm looking for two numbers that multiply to be negative 120 that combine to be 2. I could start going with 1 and 120 and 2 and 60. But if you stop and think about it, some of the numbers that we'd come up with first to multiply to be 120 would be a 12 and a 10. And they're two apart from each other. I need them to multiply to be a negative and combine to be a positive. So I'm going to use a positive 12 and a negative 10. Let's just double check. Do they multiply to be negative 120? They do. Do they combine to be positive 2? They do. So I'm going to write this as 8u squared plus 12u minus 10u minus 15. So this is going to be, let's see, I can take out of these two, I can take out a 4 and a u. So I'm left with a 2u plus 3. And out of these two, let's see, I can take out a 5, a minus 5. So I'm left with a 2u plus 3. So I can take out the 2u plus 3, and I'm left with a 4u minus 5. Now, I can't just change from and say, well, the original problem was about x's, and now I've got something in terms of u. I just need to switch this back. So wherever there is a u, we're going to replace that. We're going to reverse the substitution, so to speak, and we're going to put in an x cubed. So this is going to be 2x cubed plus 3, and this is going to be 4x cubed minus 5, and that is the answer. That's in terms of the original variable. And this is what we would get when we factor this. So we're going to take a look at the next two examples, and when we would look at these, this is not the only way to do these particular problems. There might be some other way that you might want to try, but we're going to go ahead and take a look at each one here, and we're going to use this technique. So again, these are a little bit challenging. I want you to recognize what's going on here. This exponent is double that. So what we need to do is we need to have, kind of rewrite this. This is going to be 2x squared squared. Okay, so take a look right here. So this is going to be 2x squared, and we're going to square that. So we kind of set this off, and we're going to say u equals this part right here. So this is going to be 2x squared. And then I get to replace this. So this is going to be u squared. There's a 2x squared squared. So this is going to be u squared plus u, and then minus 6. And then I'm going to go ahead and factor this. This is a pretty easy trinomial. Okay, again, we get relieved of thinking about x's and squares and all sorts of stuff like that. I just need an easy trinomial where we get numbers that multiply to be negative 6 that combine to be positive 1. So that's going to be a plus 3 and a negative 2. We'll just double check. They multiply to be negative 6. They combine to be positive 1. So this is the right factoring in terms of u. Now we just reverse this. So wherever there's a u, we're going to put 2x quantity squared. So this is going to be 2x quantity squared plus 3. And then this is going to be 2x quantity squared minus 2. We're back in terms of the original variable, so we can circle that. If you wanted to do something on this one, like go ahead and square this out and get, what do we have here, 4x squared. I'm going to write this in a different color. So this would be 4x squared plus 3, and then 4x squared minus 2. You could do something like that, but we're going to leave it in this format right here where we just reverse the substitution. And that's going to help us on something like this, where what we've got is we've got this middle part, this middle variable part is going to be our u. So we're going to say u equals 2x plus 5, quantity raised to the 4th. And then we want to recognize that this would be written as 5, 2x plus 5 squared, raised to the 4th squared. Okay, so again, power to a power and multiply them. Again, we're counting on this one being double the exponent right here. So what that's going to do is allow us to write this as 5u squared, and then plus 21u, and then minus 20. And then we're going to multiply the two of these together. So because we've got to factor this trinomial, if we multiply those together, I get negative 100. And I need two numbers that multiply to be negative 100 that combine to be positive 21. To make it 100, we could do a 10 and a 10. That's pretty close. But if I use a 4 and a 25, and one of them's got to be negative, so let's see, and the middle one's going to be positive, so the bigger one's got to be positive. So I've got a negative 4 and a 25. Let's double check. Do they multiply to be negative 100? They do. Do they combine to be positive 21? They do. So I get 5u squared plus, a minus, we'll do a minus right here, minus 4u plus 25u minus 20. So we're going to take out a u. We're left with 5u minus 4. And we're going to take out a 5. We're left with a 5u minus 4. So this is 5u minus 4 and u plus 5. Again, the factoring is a lot easier without having all this 2x plus 5, quantity to the fourth and all that sort of stuff. Now all we have to do is just reverse the substitution. So wherever there's a u, I'm going to make that one look like a 4. Wherever there's a u, we're going to put 2x plus 5 quantity to the fourth. So here's what we get. 5, 2x plus 5 quantity to the fourth minus 4. And on this one we get quantity 2x plus 5 to the fourth plus 5. Now again, we're going to leave it like this. You could raise this to the fourth and then multiply everything out, collect like terms and all that sort of stuff. But we're just going to leave it as it is for right now. We're going to call that good. Okay, we're going to come back over here, take a look at this one. We've seen something like this before. So the u is going to be the square root of x, because when I square the square root of x, I get x. So this is going to be 2u squared minus u minus 1. Again, it looks a little bit better. We're going to factor this. Again, this is where our factoring skills come in handy. I need some numbers that multiply to be -2, that combine to be -1. So I've got a 1 and a 2 will make that, and I need the bigger one to be negative to make that middle one, middle coefficient to be negative. They multiply to be a negative, -2, and they combine to be a -1. So this is going to be 2u squared plus u minus 2u minus 1. So we're going to take out a u. We're left with 2u plus 1. Take out a negative out of those two. So we're left with a 2u plus 1. So we've got a 2u plus 1. And we're left from this one with a u, and from the second one with a -1. And then all we have to do is just reverse the substitution. So wherever there's a u, we're going to put a square root of x. So this is going to be 2 square root of x plus 1, square root of x minus 1, and that's it right there. So hopefully you're getting the hang of this. We're going to have u equal exactly half of that. So u equals x cubed. So this is going to be, since x cubed squared is equal to x to the 6th, this is going to be 81u squared minus 4. So then we can take this, and this is just a difference of squares, 9u minus 2 and 9u plus 2. And then we're going to reverse the substitution. So this is going to be, wherever there's a u, we put an x cubed, 9x cubed minus 2, 9x cubed plus 2, and we're done. We made it look a little bit nicer, and then we factored that. And you might make an argument that I could have just done that without this substitution, and that would have been fine. Take a look here. We've got this raised to the first, then that raised to the second. So here's our u. U is 1 over x. So this is going to be u squared plus u minus 2. And I think we already did something like this. This is going to be a u, and that's going to be a u. I need a positive 2, and I need a -1 right here. So let's see. Yeah, they multiply to be -2. They combine to be a positive 1. So I've got the right factoring. And we're just going to reverse the substitution. So this is going to be 1 over x plus 2 and 1 over x minus 1. Okay, so not too bad, hopefully. Weird technique, but it does work. And then we're going to take a look at the bottom of the page here, and I want you to notice something. We did a substitution so we could actually make some factoring a little bit easier, and I think you'll agree that on some of these it definitely was easier. You might be able to factor using some other technique. But I want to take a look at this little thought question at the end. A natural next step would be, well, why would we do that anyway? I mean, could there be something else that we could do with this? So this is just a thought question. You don't have to, we don't have any problems like this or anything. But if you ran into something like this, I want you to notice that it's written a little bit different than that right there. So again, recognizing that this middle one is 1 over x, and that the one next to it, the leading one, is 1 over x squared. What we want to do is we want to take this and we want to do something once we've factored this. So this is 1 over x quantity squared plus 1 over x, and I'm going to put that in parentheses minus 2, and that equals 0. So like we did up above, we're going to say u is equal to 1 over x, and then this is u squared plus u minus 2. We're going to factor this, again, just like we did up above. So when we factor that, we end up with u plus 2 and u minus 1 equals 0. So that means the answer we get from this one is a negative 2, and the answer that we get from this one is a positive 1. Well, if the original equation was about x's, and I've got answers in terms of u, I'm going to reverse that substitution. So I can stay with the u's and making this look a lot easier, and then I could just say, well, in the end, can I reverse this substitution? So 1 over x is equal to negative 2, and 1 over x is equal to 1, and let's see what we get here. I'm going to multiply both sides by x, so those are going to cancel. I get 1 equals, let me slide this down here. Actually, I'm going to come over here. No, I will slide this down. So I get 1 equals negative 2x, and we're going to divide by negative 2. So I get x equals negative 1/2. My computer's catching up here. And then on this one, we're going to multiply both sides by x. Those will cancel. I get 1 equals x. So there's the other answer. So what we can do here is we can take a u substitution, make a problem easier, get a nice easy answer like u equals negative 2 and u equals 1, and then we can just reverse the substitution and find the solutions in terms of the original variable x. Again, this is not something you're going to have to do on your assignment, but it's just a good thing to be aware of. All right, good luck, and let us know if you have questions.